Okay, here we go. Part 2. Oh, I'm sorry. This is practice test number 2. If you haven't seen part of practice test number 1, go. Again, these can be found if you're just lucked into this one and you don't know where to find all this stuff. Just go to nkinfinity.com. There's the website. There's my partner in crime. Come over here to New York State Teachers and click on Review. And there are the practice exams we came up. Now, if you click on Regents, there's where all the Regents exams are. There's only 3 of them. That's it. So I got this little link here. If you got to the wrong place, you can click on the 5 additional exams. It takes you over here to practice. And again, I also have about 300, 250, 300, whatever this is, questions that you can practice as well. And lots of practice. There will be some topical review. I don't have that yet. You'll notice it says not yet, coming soon, because there's just not enough hours in the day for me to get all this stuff done. But anyway, let's get started. Not this. That's my website. So, oh, there we go. All right, so here we go. Let's get started. The histogram below shows the ages of cars in the parking lot of Hilton High School. Okay, clearly only a few kids own new cars, and then lots of kids own cars here. Now, I could have asked about the skewness of this graph, but that's really an Algebra 1 topic, but there it is right there. That would be it. It's skewed to the left, to the left, to the left. Now remember, skewness follows the tail. So the tail's down here, you know, like a little tail down here, tail's down here. So there's the tail, there's the head. So the skewness follows the tail. Excuse me. The other thing you have to remember, excuse me, Dunkin' Donuts coffee, it's not only delicious, but it gets rid of coughs, especially when it's cold. Yuck. Anyway, it's only yuck because it's cold. The other thing you have to remember is the mean gets pulled down by the tail. The mean is very susceptible to outliers and to the tail. So the mean, because there are a lot of low numbers down here, is going to get pulled off into this direction. So the mean will get pulled off here. Remember, the mean is susceptible to shifts in the distribution. So the mean's going to get pulled off this way, whereas the median will stay relatively consistent in the middle. So somewhere in here will be the median. So those are the big topics of skewness and median and all that stuff. So the mean follows the tail. So the mean age is greater than the median age. That is not true. The median age is greater than the mean. Yes, the median age is greater than the mean, so check. The median is somewhere between 6 and 8. Well, I put the median right there, about 7, so 6 and 8. I'm going to say that's check. There's my answer. All right, next question. Ooh, the maximum point on the graph of f of x is this. So whatever the graph looks like, 2, -3, somewhere here, that's the maximum. If it's going down like this, maybe it's an absolute value, maybe, I don't know what it is, but that's the maximum value. Now you have to know what transformation takes place here. This is when we add or subtract on the inside of parentheses. That is a shift horizontally left or right. In this case, it's always left or right backwards. In any case, it's always going to be left or right backwards. So while this is a -4, we're actually going to shift to the right 4 units. So if I take this point and I go to the right 4 units, instead of it being 2 -3, it's now going to be 6 -3 because it just moved to the right 4 units. 6 -3, there it is. Don't get swayed on the fact that, oh my God, because it's maximum, it's got to go up and down. It didn't go up and down at all. It just moved to the right. There it is. The formula for the nth term of the sequence. Now, did you notice they didn't tell us whether it was arithmetic or geometric? But the fact that it flip-flops back and forth between positive and negative clearly means it's geometric. You're not going to add something and it becomes positive, and then add that same thing and then it becomes negative, and then add that same thing again and it becomes positive. It's not going to happen. So what are we doing? We are taking our first term and we're going to multiply it by 2. Multiply it by 2. But that wouldn't get us from negative to positive, so our common ratio, remember, if we're going to find the common ratio, you take the second value and you subtract by the first value, and you get -2. And if you keep doing that, you'll always get -2. So our common ratio is -2. And if you remember the formula, it's a sub n. Let's see, I think that's on the formula sheet. Geometric sequence. Yeah, there it is right there. There's my common ratio. So once I have that, it's a relatively simple problem. We just take the first term, which is 3. We take our common ratio, in this case, which is -2, and we raise it to the n minus 1. There it is, choice 4. All right, kids, here's another one that you could do using your calculator. You could take the number like 3.6 and stow it into A, and then type this whole thing in, and type in your answers and see what you get. One of them's going to match up. That'll get you the right answer every single time, but I think you should know how to do math. So we're going to do this like this. That one I don't have a problem with. This one I have a problem with. This is backwards. Now, if I want to be able to add these up, I need to have those be exactly the same. I like to call this, when they're backwards, I like to call it the -1 rule. Because if you take 1 minus a and you take out a -1, if we factor out a -1, right? So what am I going to get left over when I'm taking a -1 away from each of these? So what I end up with is -1, -1, plus a. Now, why is that? Well, think about it. If I take this -1 and redistribute it, I get +1. Check. If I take this -1 and redistribute it, I get -a. Check. Well, because now I have addition, and addition is commutative, I can just change that order to a minus 1 and still leave that -1 out front. So this is -1, a minus 1. Now, I don't need to leave this negative in the denominator. Just like if I had 3 over -4, 3 over -4, that's the same as -3 over 4. In fact, we don't really like negatives in the denominator. We always bring them to the top. So I'm going to get rid of this negative down here, and I'm just going to put it up top. So now I've got 3 over a minus 1 plus a -3 over a minus 1. That gives me 0 over a minus 1, which is just 0. And you would find no matter what value you put in for a, you would always get 0. By the way, don't put in 1 for a. You'd have lots of problems. It would crash. Product. Product means multiplying. These we need to multiply together. So multiply these two together. 5 times 2 is 10. The square root of 2 times the square root of 2 is just 2. Multiply these two together. I've got minus 4i square roots of 2 plus 25i square roots of 2. And then finally, these two multiply to give me -10 I squared. Now remember, I squared is really -1. You have to remember that. All right, so this is 20 plus 21I square roots of 2. Just put these two together. Plus 10. Now why plus 10? Because this is really -1, which makes this a plus. So I'll put those together and I got 30 plus 21I square roots of 2. Again, that's another one you could have just typed into your calculator. It would have given you a crazy decimal, weird looking, complex number, but you could have done it. And then you just give me you just put the answers in, the final answers in, you get the same thing. So anyway, what do we got here? What do we have here? All right, so I can graph this one. In fact, let me do that one. I want to make sure I graph this one because it's actually pretty easy. Just so you know, this is already in vertex form. This is the vertex. So this is the vertex 4, -5. And because this is positive, it's going up. So it's going to look like this. 4, -5. It's going to be here, and it's going to be going up. So my range is from -5 to infinity. And again, range is y values, so we don't want to pick these. And so 4 is my answer. But I can also do this graphically. 3, how do you get to absolute value? Well, you click on this little crazy button right here, and you give all this stuff. We're going to do absolute value of x minus 4 and then minus 5. And again, there it is. The lowest value, if you want that value, you can always go menu, analyze the graph, minimum, click, click. There it is, 4, -5, just like I said. So the lowest y value is -5, and you go up. Make sure you're not picking x values. You're not picking those x's. So this one's an interesting question. M is just some value, right? So if we use some value, y equals 2 to the x, y equals 3 to the x, y equals 4 to the x, y equals 1/2 to the x, y equals 1/3 to the x, whatever m is, right? So what value do they all pass through is what it's saying. They have to pass through this question. So if I come over to my graphing calculator, for those of you that did a nice job with exponential functions, you probably already know the answer, but you know what? Let's take a look. So, how about 2 raised to the, 2 raised to the x. And then hit tab. And then 3 raised to the x. And then 1/2 raised to the x. Oh, tab. 1/2 raised to the x. And then tab, let's go 0.258 raised to the x. Where do they all go through? What is the one point they're all going through? That thing right there. Well, what is that point? That point, well, that point is 0, m. Wait, hold on a second. The graph passes to the point, 0, 1, but 0, 1 is not one of my answers. No. 0, 1 would be a point they all pass through, but that's not, I thought this was an easier question. Okay, so, now maybe I should check these. This would go through the point. If I plugged in a 1 here, that would give me 2. If I plugged a 1 in here, that would give me 3. If I plugged a 4 in here, that would give me 4. If I plugged a 1 in here, that'd give me 1/2. If I plugged a 1 in here, that would give me 1/3. So these are all going through the point 1, whatever m is. Right? That's one of the ways to tell what the function base is. If you go to the table here, Control T, this is one of the things we talked about. If I plug in 1, that will tell you the base. The base of the first one was 2. The base of the second one is 3. The base of the third one is 1/2. The base of the fourth one is 0.258. So plugging in 1 actually will tell you what your growth rate is. It'll tell you what that base is, which is what your growth rate is, or in this case, decay rate or growth rate. All right, that one's done. Sine equals 1/2 terminates in the second quadrant. What is the value of this? Ooh-wee. Well, first of all, cosecant is just the reciprocal function of sine. So I know this one is 2. Now, what's the other one? I don't have a clue. But remember, we're terminating in the second quadrant. First thing I know about cotangent in the second quadrant is all students take calculus. This is tangent and cotangent are positive. This is cosine and secant are positive. This is sine and cosecant are positive, and everything's positive here. So I know when I'm in the second quadrant, whatever I come up with is cotangent is negative. Remember, sine is opposite over hypotenuse, so this is 1 and this is 2. And if you do the Pythagorean theorem to figure out what this is, you find out this is equal to the square root of 3. So what is the cotangent? Cotangent, well, let's see, tangent is opposite over adjacent. So cotangent is adjacent over opposite. So adjacent would be the square root of 3 over 1. But remember, it's negative. So this becomes negative square root 2 square roots of 3. There it is. Choice 1. Tough problem. We got to practice that one. I know my kids got to practice those. We did not do enough trig this year. It makes me mad. If this is a 0, what is another 0? I could just graph this. In fact, let me show you how to do this graphically. I'm going to show you how to cheat, and then I'm going to show you how to do this the right way. I hate showing you the cheat, but I do want to show you some things. X cubed, I don't think I do enough on the calculator because I hate the calculator. I think you should be able to do these mathematically, but come crunch time, you want to have a couple of options on how to do these problems. Minus 23x plus 60. So it said 3 was a root, right? Well, there it is. 3 is a root, 4 is a root, and negative 5 is a root. 3 is a root, 4 is a root, negative 5 is a root. So the answer to this question is number 1, negative 5. Now, what would you do if this was not it? If you had to do this, if this was a part 2 question? Well, the first thing you need to do is know that this is x minus 3, and you're going to divide it into x cubed minus 2x squared minus 23x plus 60. All right? And if I do that, I get x squared. So this is x cubed minus 3x squared, right? Because you're going to multiply it by both those down there. Subtract. So this is x squared minus 23x. Multiply by x. So I get x squared minus 3x. Subtract. This turns into positive. So I get negative 23x. Bring down the 60. Excuse me, negative 20. Bring down the 60. Multiply by negative 20. So I get negative 20x plus 60. Subtract. Turns this into a plus. Turns this into a minus. And you should end up with 0. If, in fact, it's a 0, you should end up with 0. And then this thing you just take over here and you factor it. X plus 5, x minus 4, and your two answers are x equals negative 5 and x equals 4. So that would be the long division approach. The graphical approach clearly was the better choice here. Either way is fine. So which relationship between the two students, which one's the best relationship between these two students? Blah, blah, blah. We got Michelle and Valerie. Hard to tell, so let's put those things in our graphing calculator. Whether you have the 84 or not, you can do this. So we're going to call this Michelle and this Val. I don't think you can use Val, so let's use Valerie just for fun. So Michelle's scores are 71, 68, 84, and 88. Oops, maybe I don't want to put Valerie here. Maybe I want to do her on a different one. So menu, analyze statistics. Let's do stat calculations, one variable statistics, one list. We'll call it Michelle. Click OK. So this is Michelle's information. She's got an average of 77.75. So Michelle has an average of 77.75. That's her X bar. Her standard deviation is 8.44. So 8.44. Got to use population because I'm assuming these are all the test scores. So now let's do Valerie. So control doc. Oh yeah, control doc. List of spreadsheet. We'll add a new one. So now we'll do Valerie. And we go down here. We put in Valerie. She got a 78. She got an 82, 86. Hers look more consistent. So she looks like she might have a lower mean, but maybe she has a higher mean, lower. She definitely has a lower standard deviation because her scores are much more consistent. So menu, statistics, stat calculations, one variable statistics, click OK. We want to do Valerie. Valerie's got, she's got a higher average too. 80, so she's got a higher average. So her average is 81.5. She's much more consistent. Her standard deviation is going to be much lower. 2.9, way low. All right, so 2.9. So Michelle's mean test score is greater. Nope. Michelle's population standard deviation is greater. Yes. Valerie's mean test score is greater, and her interquartile score is greater. Oops, we don't know about that one. Valerie's mean test score is greater, but her population standard deviation is smaller. Oh, this is the right answer. I didn't finish on this one. Michelle's population standard deviation is greater. That is true. Her range is smaller. Her range goes from 68 to 88. That's 20. This one's range goes from 76 to 82. That's only like 6. So that's not true. I missed the second part. And Valerie's mean test score is higher, but her interquartile range is lower, not higher. It's less spread out. Choice 1. 2 left, kids. A support wire 20 meters long runs from the top of a utility pole to the ground at a point on the ground 17 meters away. And we're assuming the ground is perpendicular, or the pole's perpendicular to the ground. What is the measure to the nearest minute of the angle formed by the pole? Well, wait. The angle formed by the pole and the wire. Oh, I almost misread that because we always use this angle down here, but they want the pole and the wire. Remember, this is my pole, and this is my wire. So I want this angle. So I'm going to label this O, A, and H. This is opposite now that this is my hypotenuse and this is my adjacent. So I need to use opposite and hypotenuse. So sine of theta is equal to opposite, which is 17 over 20. Now, because I want to find an angle, I'm going to bring that sine over, and we're going to do inverse. We're basically inverse sining both sides. Sine inverse. Not basically, that's in fact what we are doing. But we're going to slide that over. We're going to inverse sine this. But we also have to remember to DMS it. We got to round it to the nearest, what do we round this nearest to? Nearest minute. So I'm going to go back to my calculator, and I'm going to do sine. It doesn't like when I use this. Sine, oops, I don't know why we're doing this. Come on. Sine inverse of 17 divided by 20. And then I'm going to DMS it. So I'm going to go to my catalog here and hit D and scroll down until I get DMS. Oh my God. F part, U part, Q part. First of all, I'm in degree mode. I should be in degree mode. Let's change this to settings, document settings. Let's go approximate. Sometimes this thing just loves to give me strange answers. There it is, 58 degrees, 12 minutes, 40. So 58 degrees. Here's the hard part, 12 minutes, 42 seconds. Now you would think 42 seconds, oh, we'll stay at 12. But remember, 30 seconds is the cutoff for rounding. So this is 58 degrees, 13 minutes, not 12 minutes. All right, finally this. Which graph below represents the inverse? Now, inverses are reflections. I never spell that word right. Over the line y equals x. Math teacher not be able to spell reflections right. I always spell it with an x for some reason, like I wanted to be cool. All right. So there's the line y equals x. I need to reflect it. Well, this point here, which is 0, 1, y equals x, is going to go through the point 1, 0. Now, let's see what we got here. Let's make up a point. This point looks like it's about negative 310. Negative 310. So let's go 10, negative 3. This point here looks like it might be 4, 0 almost, 4 point something. So let's go point something 4. And so my inverse, as crazy as it seems, is going to look something like this. Because those are reflections over the line. The key is this point. I will tell you that right now. The key is this point. Because you need to find the one that also goes through 1, 0. So, not 1, not 2. Now these both go through that, but which one is the reflection of this? What's the mirror image of this? And that would be choice 4. The right answer. All right, kids. We are done with the multiple choice. We will now move on to the dreaded part 2s, 3s, and 4s. All right, kids, hit the like button, hit the subscribe button. Tell me what you think.